So today we are going to learn how to write an absolute value inequality, not equations, how to write an absolute value inequality given its graph on a number line, okay? But before we get to the actual notes right there, we have some warm-up problems. Here's the first one. So we have two inequalities separated with the word and. We're going to solve each of them. So on the left one, we subtract one. We're going to end up with x is less than 3. On the right one, we add 2. We're going to have negative x is less than 8. And then for your final step, you're going to divide both sides by -1 or multiply both sides by -1. Either way, you're going to have to flip that inequality symbol. It's going to become a greater than symbol, -8. So we have two answers. We have x is less than 3, and we have x is greater than -8. And there is the word and right between them, which implies that there has to be an overlap. It has to be both. So we need to know how to present our answer. We're going to go to a number line to find out how to present our answer. And you're going to put the smaller number on the left side, which is obviously the negative number, -8. You're going to put the bigger number on the right side, which is obviously the +3. And then you're going to graph accordingly. X is less than 3 is an open dot at 3. Less than is this way. And x is greater than -8 is an open dot at -8. Greater than is to the right. So you do have an area that's together. The word and implies an overlap. So where's it overlapping between here and here? Okay. So because it's an area that's together, we're going to have to write it as a compound inequality written together. And that's one of the easiest things to do if you already have it in the form of this number line. Because the smaller number is already on the left side, the bigger number is already on the right side. So you just rewrite it, -8, +3, x in the middle. And because the bigger numbers are on the right side, both of these inequalities have to open up to the right side. Smaller number on the left, the bigger number on the right. They both have to open up to the right. And that's your compound inequality answer. That's what you're going to put for full credit if you had this question on Thursday's test. Are you with me? Okay. So we're going to do a couple of more of these with the words and or. Let's do them. Here we go. Go ahead and copy this one down right here. Once again, we're going to do one at a time. Let's solve this one first and then that one. Then we'll worry about the word and between the answers. So Mariana, what would I do for my first step on solving this one? I want to get x by itself. What do I do? Add 5. Thank you very much. What you do to one side, do to the other. We're going to rewrite it. -3x is less than 6. Mariana, what would my next step be? Yep. You want to get rid of the multiplication, so you're going to divide by that exact value, -3. What you do to one side, do to the other side. You're going to have x. And Mariana, do I keep the inequality or do I flip it? Flip it because I divided by a negative, so it becomes a greater than. So I have x is greater than -2. That is our answer for the inequality on the left side of the word and. Now let's solve this one over here. Let's ask Caitlin. Help us out, Caitlin. What do I do for my first step right here to get x by itself? We're going to add 1 to both sides. Okay, so +1. I rewrite this thing. I'll have a 2x is greater than 2. And Caitlin, for my final step, what do I do? Yep, divide by 2. We end up with x is greater than 1. So we have our two answers here. We have x is greater than -2, and we have x is greater than 1. Now, we do have the word and right between them. So we need to look at the number line to determine if they're going to be written together as a compound inequality, or maybe just one of them is the answer, or maybe just the other one's the answer. So we need to look at a number line and think of the areas. When you go to a number line, put the smaller number on the left side, which happens to always be the negative number is always smaller than the positive. So put the -2 on the left side, put the +1 on the right side, and I want to graph the x is greater than -2 in blue. That's going to be an open dot at -2. And let me ask somebody, Jorge, the greater than symbol, is this going to go to the left or to the right? Right. To the right. Okay. And when we look at this one, x is greater than 1, open dot at 1, and Said, am I going to go to the left or to the right?
To the right.
To the right as well. Okay. So as you can see, they're both going in the same direction. Okay. And we need to now think about the word and. And on any number line where you're graphing a compound inequality, there's three areas, right? You have the left side, the middle, and the right side, okay? When you look at the left side and you think about the word and, do you have on the left side both the red and the blue? No. Do you, right here in the middle, have both the red and the blue? No. Over here, do you have both the red and the blue? Yes. So what is our answer going to be? It's not going to be the -2. It's not going to be a compound inequality with a smaller number on the left, bigger number on the right with the x in the middle. It's only going to be x is greater than 1. Does that make sense? Okay, so the only answer that you submit is x is greater than 1. That's it. Because the word and implies that you have to have both the red and the blue, and the only area that has both red and blue is right here, open dot at 1 going to the gray. So x is greater than 1. Okay. Now, if this would have been an or, then do you have a red or blue right here? No. Do you have a red or blue right here? Yes. Do you have a red or blue over here? Yes, you actually have both. So if it were the word or, then you would say x is greater than -2. You wouldn't mention the x is greater than 1 if it were the word or. And I think we have that on the next question, so let's check that out. Go ahead and jot this one down. We do have the word or. Let's see how that plays out. So once again, we're going to solve the left inequality, solve the right inequality, then worry about the word or and how it appears on the number line. So to solve this left one, we need to simplify first. So, Nate, what would I do? Yeah, you're going to go -2 times x, that's a -2x. -2 times -1, that's a +2. And you're going to bring down the greater than symbol, bring down the 5. And you've at least simplified it. Next, you want to get x by itself. So we'd get rid of the +2 by doing -2. And what you do to one side, do to the other side. You're going to have a new inequality that reads -2x is greater than 3. So to get rid of the multiplication of -2 right in front of the x, you're going to do the opposite of multiplying, which is dividing by that exact value, -2. And what you do to one side, you do to the other side. You're going to have x, and since we divided by a negative, you flip that inequality symbol, it becomes less than. A lot of people freak out with 3 divided by -2. It's pretty simple. It's just -1.5 or -1.5. Think about it. $3 divided by 2, it's $1.50, right? So you have -1.5 or -1.5, whatever you want to call it. But there's your answer to the inequality on the left side of the word or. Now let's go to the right side and solve that one. On that one, Tanya, what would I do to start getting this x by itself? This time it's on the right side, so what would I do to get rid of the 7? -7, right? And what you do to one side, you do to the other side. Okay, and you'll end up with -2 is less than -x, okay? Now, you don't want a negative x, you want a positive x. So how do you change that -x to a positive x? You either multiply or divide by a negative, right? So if you want, you can divide by -1, divide by -1, and yes, you are dividing by a negative on an inequality, which means that you have to flip that inequality symbol. So what we have here is x, but you're going to flip this less than, you're going to flip it to become greater than. And you have +2 on this side. Now, this is your answer, but if you read it, you're going to be reading it with regards to the 2. It says 2 is greater than x, right? But we don't want to talk about 2, we want to talk about x. So you could either read it backwards or actually flip it in the correct order it's supposed to be in, where you have the x on the left side, the 2 on the right side, and if it did open up to the 2, it has to continue opening up to the 2. I hope everybody understands that. So we have our 2 answers here with the word or right between them. The question is, how do we present our answers? Will it be both of them with the word or between it, or is it just going to be this one, or is it just going to be that one? In order to determine that, you have to go to a number line and see where the areas are at and think of the word or. So let's put the smaller number on the left side, the -1.5, put it on the left side, and put the +2 on the right side. And let's graph this one in red. X is less than -1.5. Less than is to the left. And the other one, let's graph in red. X is less than 2. Open dot at 2. Less than is also to the left. Okay. And like I said before, whenever you graph one of these compound inequalities on a number line, there's always 3 areas. There's the left side of that point, the middle of the 2 points, and the right side of that point, okay? So let's think about the word or. Is there a red or a blue one over here on the right side? No, there is no red, there is no blue. Is there a red or blue one right here? Yes, there's a red. Is there a red or blue one right there? Yes, there's both. So where does it start satisfying the word or? Right here from 2 to the left. So the only answer that you put down on the test Thursday is x is less than 2. You don't write this one, okay? That's because of the word or, okay? So the only answer that you write, answer is x is less than 2. That's it. That's all you write. Now, if we would have had the word and, then it would have to be both red and blue, and that's only in this area from this value of negative 1.5 or to the left of negative 1.5. So if it would have been the word and, you would have picked this guy right here and not this guy. Does that make sense? We have to become pros at this because you're going to have it on the test. Okay, so what I want to do right now is not give you another question, but give you another hypothetical situation. Let's say you were solving two inequalities with the word and between them, okay? You have the word and between them. And you get these two answers. You get x is greater than 1, and you also get x is less than negative 2. What would your final answer be? Do you actually have maybe, like let's say on the test you have a multiple choice. Let's say you have negative 2 is less than x is less than 1. Maybe that's an answer. Or maybe it's just x is greater than 1. Or maybe it's just x is less than negative 2. Or maybe it's actually, maybe it's none of these, right? So what I want to do right now is pause it. I want you guys to talk to a partner and figure out what would the correct answer be. Okay, so I know you guys are talking, but the reality is this. You cannot conclude an answer unless you do what? A number line and visualize it and see it. See the areas and see what the word and means. It means that it has to be both, right? So if you didn't do this, you really don't have anything to figure out the answer. So let's go to a number line. Let's put the smaller number on the left side, which is negative 2, the bigger number on the right side, which is positive 1. Let's graph this one in red. X is greater than 1, open dot, greater than to the right. Let's graph this one in blue. X is less than negative 2. X is less than to the left. Now, the word and, what does it mean? We did that exercise where I said, please stand up if you have blue jeans and white shoes. It has to be both, right? The word and implies an overlap. It has to be both. So do you have both red and blue right here on the left side? No, it's just blue. Do you have both red and blue in the middle? No, there's nothing. You have both red and blue on the right side? No, it's just red. So where is it both the red and the blue? Nowhere. So what would your actual answer be? No solution, right? Which in this case, none of these, because the correct answer is not there. The correct answer is no solution. I hope we get that. And now it's time for the actual lesson, okay? I'm going to give you a graph like this one right here. As a matter of fact, go ahead and copy that graph right there in your notebook somewhere. And we're going to be able to write a compound, or not a compound, we're going to be able to write an absolute value inequality that actually produces this graph. So here we go. These are the notes. Whoops, right there. These are the notes that you guys are going to have to jot down to be able to come up with the absolute value inequality that produces this, okay? So, so on every single question that you get like this, where I give you an area on a number line, you're going to start off the question like this. You're going to start off the absolute value inequality like this. Absolute value of x minus blank spot, and then you're going to have this little area that you're going to write an inequality right there, and then you're going to have another blank spot over here, okay? So right here, you're going to write a number that's the midpoint. So what would the midpoint of these two dots be? So that will be negative 3, and it's as simple as this. You're at your two dots. Go ahead and go 1 unit in, 1 unit in. The midpoint is negative 3. So this is the value that belongs right here, where it says midpoint. So you're actually going to plug in the numeric value negative 3, okay? Now, right here belongs an inequality. If the areas are apart, use greater. And notice that I misspelled it, greater. Why do I put or instead of ER? Because usually when the areas are apart, it's going to the left or to the right, which means that you have the word or in it. So if the areas are apart, you're going to use greater than. If the areas are together, like right here, if the areas are together, you're going to use the less than symbol. So obviously, this is going to be a less than symbol, okay? Because the areas are together. Now, these are solid dots, which means you're going to have a solid line underneath that inequality. And over here on this side, you have the distance from the point to the midpoint. So from a point to the midpoint, what is the distance? You're going 1 unit, 2 units. Doesn't matter if you go that way or this way, 1 unit, 2 units. So this number out here will be a 2. And ladies and gentlemen, that is your absolute value inequality that will produce this graph right here, okay? So the goal for today's lesson, I mean, we did all that review, all those review questions, but here's the actual lesson. You have to memorize absolute value of x minus a number, close absolute value. You're gonna have either a greater than or less than, depending on if they are apart, it's greater than, because it's going that way, or if they're together between here and here, it's a less than symbol, okay? And then over here, you have a number that's the distance from the point to the midpoint, okay? The only other thing you could do to make this look a little bit nicer is change the minus minus to plus plus. So it would look a little bit nicer if you have the absolute value of x plus 3 is less than or equal to 2. There is your absolute value inequality that'll produce this area that's together with solid dots. In other words, if I told you to solve this, it's already isolated. And if you set up your positive situation and your negative situation, you would get the two answers that are pointing towards each other, -5 and -1, with an area that's together, okay? So again, you're gonna set this up every single time. Absolute value of x minus something, close absolute value. You're gonna have an inequality right here, and then the distance from the point to the midpoint, okay? The only way to get good at this is to practice. And that's why on Google Classroom, I have a picture of our textbook. That way you don't actually have to open up your textbook. We have these questions right here. And we're going to do these right now in class. And every single time, you're going to have to set this up. The absolute value of x minus blank spot. And in this blank spot, you're going to put the midpoint. I'm just going to put MP right there as little notes for us. And then we're going to have a little inequality right here, okay? And then on the outside, on the right side of the inequality, you're going to put the distance from the point to the midpoint. So go ahead and pick any one of these. Which one would you like to see? 23, 24, 25, 26, 27, anyone, which one? 26. All right, let's take a look at 26. And we obviously have a midpoint that's where? What is the value that goes right here inside of the absolute value? What is the midpoint of these two dots? 1. 1 is the midpoint, right? Okay, so we're going to put a 1 right there. And then we need to deal with the inequality. Is it going to be a greater than symbol or a less than symbol? Greater, because the areas are going apart. Okay, so greater than symbol. Let's put a greater than right here. And then, are these solid dots or open dots? Open dots, so I'm not going to put a solid line underneath it. And over here, the number is the distance from the point to the actual midpoint, which is 1. So what's the distance from here to 1? 2 units. So you put the 2 right there, and you're done. Is that easy or what? Super easy, right? Okay. Let's practice. Whoa, that's ugly. Let's practice some more. Pick another one. Which one do you want to see? 30. Okay. So once again, you're going to set this up all the time. Absolute value, x minus, right here goes the midpoint. Close absolute value. Right here goes your inequality, depending on if it's apart or together. And then over here, you have your distance from the point to the midpoint, okay? So let's begin with the midpoint itself. What is the midpoint? It is 5. Now, you're probably thinking, what? What do you mean? Well, think about it. You're right here. Go 1 in, and then go 1 in, which are going to be right in the middle. And notice that these are going by 2s, right? 0, 2, 4, 6, 8. So you're actually right here in between 4 and 6, which is the midpoint 5. So you could actually, I'm going to put 5 right there. That's my MP, my midpoint. So I'm going to put a 5 right there, okay? Now, with regards to greater than or less than, greater is when they're apart, less than is when they're together. So obviously this is together, so it's a less than symbol, right? So we're going to put less than right here. And not only that, these dots are what? They're solid, which means I need a solid line underneath that inequality. So put a solid line underneath that inequality. And over here, we need the distance, right, from the point to the midpoint. So what is the distance from here to here? You got to remember that you're going by 2s, right? That's 2, and then half of 2 is 1. So what's the distance? 3. So you put a 3 right here. And ladies and gentlemen, we are done. You just plug it in and you're done, right? The only thing that you got to worry for, or not worry, but like if you ever have, like let's say your midpoint would have been somewhere over here, like let's say -6. Then when you plug in a -6, you have a minus -6, then you change to plus plus. And that's about it. I don't know, do you guys want to see one with a negative midpoint? Okay, how about 29, why not? Okay. So, every single time, set it up. Absolute value, x minus midpoint. What is a midpoint? -3. So you're going to plug in -3 right there, okay? And then how about the inequality itself? Is it a less than or is it a greater than? Greater. Okay, greater. Do I need a solid line underneath it? No, I don't. What is the distance from the point to the midpoint? It's only 1, so you just put a 1 out there. And the only thing you can do to make it look nicer is change the minus to plus plus, and you're done. Absolute value of x plus 3, close absolute value, is greater than 1. And that's it. Pretty easy, right? Again, the only way to get comfortable with this is to actually do it. So I am going to leave these questions up on the board. I recommend getting your Chromebook out so you could actually zoom in to each of these. So like if you're doing 27, you got to be able to zoom in to actually think of what the midpoint is, right? The midpoint here is, it's right between these two. What would the midpoint be right there? 2, that's right. And then you got to be able to calculate what's the distance from a point to the midpoint 2. And these are going by 4. 4, 8, 2 more, 10, right? So open up your Chromebooks. That way you could actually zoom in to count the distance, and so you could zoom in and see clearly what the midpoint is. And we're going to do this for the rest of the period.